Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to learn how to name organic compounds that contains the functional group aldehyde. To do so, the first step is to find the longest consecutive carbon chain. And very similar to, for example, naming alcohols, naming thiols, naming alkenes and alkynes, we're going to find the longest consecutive carbon chain that contains the aldehyde functional group. And so this term, CHO, is going to represent our aldehyde, and it's just written in condensed form. And so if we expand that out, CHO translates into this carbonyl carbon that's covalently bonded to the carbonyl oxygen and its hydrogen. The last bond that's going to be attached to that carbonyl carbon is going to be the R group, which is going to represent any alkyl chains, including possibly a hydrogen. And so once we've identified the longest carbon chain that contains our aldehyde, we're going to go ahead and name that parent name. So we can go ahead and name it as an alkane first, and then modify that alkane name to fit what we are working with. So for example, if we have a double bond, then we're going to convert the alkane to an alkene. If we have a triple bond, we're going to convert the alkene or alkane to alkyne. So it doesn't really matter which suffix you use, ane, ene, or ein. You guys are going to drop the last e, and then you're going to add this suffix al. And so al is going to communicate to the audience or to the reader that there is an aldehyde in the organic compound. And so that suffix al is coming from the first two letters of the word aldehyde. And so I'm just going to zoom in the space real quick. So if we have the skeletal structure of an aldehyde based on what we talked about in previous lecture videos, we know that aldehydes are terminal functional groups, meaning that these aldehydes are only found on the ends of a chain. And so, for example, it could be found on this end of the chain, or if we want, we can put an aldehyde on this end of the chain. Either way, it is the main point is that the aldehyde is not found in the middle of it's not found in the middle of the carbon chain. And because it's not found in the middle of the carbon chain and it's only found at the very ends, and since we want our functional group to always have the lowest possible carbon number when we're creating our numbering system for our organic compound, that means that the carbonyl carbon is always going to be carbon number 1. And so since the carbonyl carbon is always carbon number 1, we're going to omit the 1 from the naming of the aldehyde. Okay. It's very similar to cyclic alcohols, where the moment you have a hydroxyl group on your cyclic alcohol, that carbon that has a covalent bond with the hydroxyl group, that carbon is always carbon number 1. And so to reduce redundancy in the name of that specific organic compound, that number 1 is going to be omitted. Same scenario here. Since the carbon of the aldehyde, the carbonyl carbon, since it's always found on the terminal ends of a carbon chain, that carbonyl carbon on the aldehyde will always be carbon number 1, and so therefore there's no need for you to communicate to the reader that it is on carbon number 1. In other words, you don't want to write down that 1 in front of the parent name. And so we're going to go ahead and look at lots of examples that will highlight this point. And so our very last step is to apply other rules of nomenclature, such as the rules for naming substituents, naming double bonds or triple bonds, and the list goes on. So aldehydes, they also have common names that you guys can use. And so these common names can only be used for very simple aldehydes. And so if you have a 1 carbon aldehyde, and so you'll notice that there's no other carbons except for the one that I highlighted, that's known as formaldehyde. So the common name for a 1 carbon aldehyde is formaldehyde. If you have a 2 carbon aldehyde, then its common name is acetaldehyde. If you have a benzene ring and directly attached to that benzene ring is an aldehyde, then this whole structure, its common name, can be simplified to just benzaldehyde. Now, if your organic compound that you're trying to name is not any one of these, then you guys are going to follow the rules of the IUPAC nomenclature for aldehydes to name it. All right, so what we're going to do is we're going to go through several examples, many examples, just to demonstrate how we can apply the rules that I kind of covered to name these organic compounds. And so our very first step is to find the longest carbon chain that contains the aldehyde. And so my aldehyde is here. Therefore, this is carbon number 1. Now, if that's carbon number 1, there's really only one way for me to go next, which is to the left. And if I were to go down, that's a 3 carbon chain, but there's so many other carbons here that I could highlight. So that's probably not it. So if I go from right to left, I have 1, 2, 3, and then 4. And so I'm going to go ahead and, since I know my numbering system starts with the aldehyde, that's going to be carbon number 1. I'm just going to go ahead and number this right away. So this is 1, 2, 3, and 4. So since I have a 4 carbon organic compound, that's going to translate into bute. And since they're all single bonds, this is butane. And so according to my rules, I'm going to go ahead and erase that E in butane, and then I'm going to replace it with Al. So this is going to be butanal. Now, traditionally, I would want to put a 1 in front of this butanal to describe the carbon number in which this specific functional group is found. However, since the carbonyl carbon is always carbon number 1, we're going to omit, we're going to go ahead and erase this. We're going to omit that from the name. And so the only thing that's left for me to do is just to name my substituents, and this is something that you guys should be familiar with by now. And so all the other carbons I didn't highlight, that's going to be in green to represent the substituent. Here I have a methyl group on carbon 2. methyl group in carbon 3. And so since I have two methyl groups, I'm going to go ahead and combine them together and describe them as 2,3-dimethyl butanal. And so since I omitted the 1 to describe the carbon position of the aldehyde, then I don't need to put a dash between two letters. I can just, everything is just one word. So 2,3-dimethyl butanal. And that would be the name of this compound. All right, so in our next example, my first step is to find the longest carbon chain that contains the aldehyde. Well, my aldehyde is right here, my CHO. And so if I follow it up, then that's going to be my next carbon. And so now I have two choices. I can go to the left or go to the right. And so I want the longest carbon chain possible. So the only path that is left for me to take is going to be the one on the left, simply because I have more carbons on the left than I have carbons on the right. And so if I count off the number of carbons I highlighted, I have 1, right? So since this is my aldehyde, I'm automatically going to go ahead and make this carbon number 1. So then this is going to be carbon 2, carbon 3, carbon 4, carbon 5. And so since I have a 5-carbon compound, I'm going to be using the prefix pent. And since everything is a single bond, I'm going to go ahead and say pentane. And so I'm going to erase that E to represent the aldehyde. So I'm going to say pentanal. I'm going to omit placing this 1 in the name in my final answer, because I know that aldehydes are always terminal functional groups, and therefore the carbonyl carbon is always going to be carbon number 1. Now the last thing I'm going to do is to name my substituent and describe what carbon number it's covalently bonded to. So since this is a 1,2 carbon compound, I know that this is an ethyl. And this ethyl is going to be on carbon 2. So I'm merely just going to copy that down. I'm going to describe that in my name. So I have 2-ethyl pentanal. And so since I omitted the 1 from the name, I'm going to go ahead and scoot the substituent closer to my parent name. And so my final answer is 2-ethyl pentanal. All right. So let's go ahead and take a look at these 3 examples. Looking at the one on the left, so I'll go ahead and zoom in. This is a 1-carbon aldehyde. And so there's 2 ways for you guys to name these simple aldehydes. First, you can go ahead and use its common name. So if you remember the common name of a 1-carbon aldehyde, that's going to be formaldehyde. Now, if you guys didn't know or remember the common name of a 1-carbon aldehyde, you can go ahead and use the IUPAC convention to name this 1-carbon aldehyde. And so since it's 1 carbon, we can go ahead and use the prefix meth. Since everything is a single bond. And so the single bond that I'm looking at is with the R group, right? I know that there's a double bond between the C and the O, so I don't really count that. So since I know that there's a single bond between the carbon and the hydrogen, I'm going to go ahead and use methane. I'm going to erase the E, and I'm going to add the AL ending to represent the aldehyde. And that's it. And so remember that the carbon number 1, or the number 1 is omitted when naming aldehydes. So looking at this 2-carbon compound, there's 2 ways, once again, for you guys to name this. You can go ahead and use the common name. In that case, it'll be acetylaldehyde. And if you guys didn't know that, or if you guys couldn't remember it, you guys can always use the rules of IUPAC nomenclature to derive the IUPAC name for this specific organic compound. And so since we're dealing with a 2-carbon compound, we know that we're using eth, since everything is a single bond, excluding the carbonyl oxygen to the carbonyl carbon. We know it's going to be ethane. And so what we're going to do is we're going to drop the E, add the AL ending, and since the carbon number for the carbonyl carbon 1 is typically omitted in the final name of the organic compound, this is just going to be my final answer, ethanal. All right, so going through the next example, find the longest carbon chain that contains the aldehyde. That's carbon 1, 2, 3, 4, 5. Here there's no substituent, so I don't need to put anything in front of the name of my parent chain. And since I have a 5-carbon chain, this is just going to be pent. Since I have all single bonds, this is going to be pentane. And then I'm going to go ahead and drop the E, and I'm going to write pentanal. And since this carbon number 1 is omitted from the final name, this is going to be my final answer. There's no substituent, so there's no point for me to put anything in front of pentanal. All right, so let's go ahead and look at the next compound here. Longest parent chain, 1, 2, 3, 4, 5. That contains the aldehyde. We know that this carbon number, we know that the carbonyl carbon is going to be carbon number 1 in this organic compound when creating the numbering system for this organic compound. And so therefore this is going to be 2, 3, 4, and 5. So since I have a 5-carbon compound, I'm going to go ahead and say pentanal. So I'm already jumping into the final parent name for this structure. And the only thing that I have yet to describe is the chlorine. And so I'm going to go ahead and put 2-chloro pentanal. And once again, the number 1 is going to be omitted from the name. So I'm going to go ahead and skip this one. Well, actually, I'll do this one very quickly. That's a 4-carbon chain, and there's no substituents. So this is going to be butanal. And you're done. Okay. Now here, it looks like we have a 1, 2, 3, 4-carbon chain, but there's a methyl group. And so if this is carbon number 1, this is 2, this is 3, and this is 4, the final answer is going to be 3-methyl butanal. All right, so hopefully you guys understand the generic pattern on how to incorporate aldehydes in naming these organic compounds. We're going to do a couple more examples here, and I'll do them very quickly. And then we're going to go ahead and look at a few examples that are just a little bit more complicated, in which they involve like a double bond and stuff. And so, first step, we are going to identify the longest carbon chain that contains an aldehyde. That carbonyl carbon is always going to be carbon number 1, so our numbering system is already kind of set into place. We don't have to take into consideration whether or not we have to go left, right, or right, left. And so it looks like I have 2 substituents here. Since I have a 6 carbon chain, I know that I'm going to end this with hexane. And so since they're all single bonds, I'm just going to go ahead and write hexanal. I'm going to omit the use of putting number 1 to describe the position of the aldehyde. And the only thing that's left for me to do is to describe the carbon number in which these methyl groups are covalently bonded to. And so this is going to be 3,4, 3,4, dimethyl hexanal. And everything is one word, no dash, no comma. We're going from letter to letter, L to H. And so this is going to be our final answer for this compound. Looking at the next example, here we have 1, 2, 3. And so it looks like we have a 3 carbon compound. And so we're going to go ahead and use the prefix prop or propane. Now, once again, for aldehydes, we're going to drop that E and add the Al, so that's propanal. We know that this is carbon number 1, therefore this is 2, and that's 3. So it looks like I have 2 substituents. I have a methyl on the second position. And then I have a bromo on the third carbon. Here, when you have different substituents, you want to name them in alphabetical order. And so you're going to put the B, the bromo, first. So here we have 3 bromo. And then we're going to describe the methyl next. And since I'm going from letter to letter, I'm going to go ahead and scoot everything over. So it's just one word. No dash, no commas, no space. Okay. And so once again, like naming these substituents should be nothing new to you guys. The only thing that we've really added to our collective knowledge of naming these organic compounds is the use of the incorporation of aldehydes, this Al suffix, into the name. In addition, omitting carbon number 1 for the carbonyl carbon that's on the aldehyde. So I'm going to go ahead and work through these 3 examples. These 3 examples are a little bit different than the ones that we've seen for aldehydes, just because it has a double bond. And so we'll see how to name organic compounds with a double bond. So our first step is going to figure out the longest carbon chain. 1, 2, oops, 3, 4, 5, 6. So it looks like we have a 6 carbon chain. So I'm going to go ahead and use hex. And I see that I have a double bond, so I can't use hexane, I have to use hexene. And so I also notice I have an aldehyde, making this carbon number 1. And so I'm going to have to erase my E and add my Al. So pronouncing this is hexanal. And once again, I'm going to omit putting carbon number 1 into my final answer, just because I know that my aldehydes are always going to be on the terminal ends, and therefore its carbon, the carbonyl carbon, is always going to be carbon number 1. So that tells me the numbering system that I have to follow for this organic compound. So that's like one of the cool things about aldehydes versus like alcohols and stuff. Alcohols, you still have to figure out the numbering system. Same with alkenes and alkynes, but you know, once you get to aldehydes, wherever your aldehyde is, that's carbon number 1, right? So it's pretty simple in a sense. You don't have to figure out, you don't have to go left, right, right, left, and all of that stuff. All right, and so the next thing that I want to do is describe the position of my substituent and the position of my double bond. Now, when you guys are describing the position of your double bond, it's always where it starts. It has to follow your numbering system. So if this is carbon 1, this is carbon 2, this is carbon 3. Oh, look, carbon 3, we have the beginning of the double bond. And so to describe the start of this double bond, this En, we're going to go ahead and put a -3 in front of the parent name. And so this 3 is going to represent the position of that double bond. And so here, this is going to be a methyl group, so we're just going to say 2-methyl. So when putting these pieces together, we'll just get 2-methyl. And then since we're going from a letter to a number, which is the 3, I need to put a dash. And then number to letter, I need to put a dash. Okay. And so it looks like we just have 2-methyl-3-hexanal. However, there's a problem. And the problem is this double bond. And this is something that you guys should always just try to get used to checking. Remember that double bonds induces this idea of potentially, not always, geometric isomers. And so if you guys recall from chapter 11, geometric isomers involves the use of cis and trans. And when you guys are trying to apply cis and trans, when you guys are numbering when you guys are naming your organic compound, what you want to do is you want to make sure that there is a hydrogen on the 2 carbons that is involved in that double bond. And so if I count the number of bonds that I have for carbon 3, so this is carbon 3 right here, this is 1, 2, 3. So I have on carbon 3, 3 bonds. And so that means that for that carbon to fulfill its octet, I need 1 more bond, and that's probably going to be filled in with a hydrogen. Now, if I look at carbon number 4, I have 1, 2, 3 bonds on carbon 4. And so for carbon 4 to fulfill its octet, it needs one more bond. And that element is the element that's going to fill in that bond is going to be hydrogen. And so it looks like on this double bond, we have a hydrogen on carbon 3 and carbon 4. And so when those hydrogens are opposite of each other, then we would say that the relationship is trans. And so when we're trying to apply that in the naming of this compound, we must communicate to the reader the correct geometric isomerism that the double bond has. And so in this case, it's going to be trans. And then now we're going from letter to number, so that I need a dash. So that's going to be trans dash 2 dash methyl dash 3 dash hexanal. And that would be my final answer. Okay. And so my advice to you is that when you see a double bond, see if it has two hydrogens, such that those hydrogens are placed one on each of the carbons that's connected by the double bond. And depending on their relative position, they can either be cis or trans. So let's go ahead and check out the next example. So longest carbon chain, 1, 2, 3, 4, 5. So it looks like I have a pentanal initially. But I see that I have a double bond, so I'm going to erase this A and convert it to an E. Okay, so this is pentanal. Since the carbonyl carbon is always going to be carbon number 1, that dictates my numbering system. So that's 1, 2, 3, 4, 5. So the only thing that I haven't described is the methyl group that's in carbon 3. So I'm going to say 3-methyl pentanal, all one word. Okay. And so, actually, there's a couple more things that I skipped. All right, so we have the 3-methyl down, that's the substituent. The other thing that we need to tell the reader is what carbon number does a double bond start. And so very similar to the previous example, we're going to follow our numbering system. And oh, look, there is a double bond that starts at carbon number 3. And so I'm going to put 3 dash 3 dash pentanal. And so this 3 tells the reader that there's a double bond on tells the reader that a double bond starts at carbon number 3. And on that same carbon, there's also a methyl group. Okay. All right, well, I see, if I erase all of this stuff, I see that I have a double bond. And whenever I have a double bond, I have to think about potentially a geometric isomer. And so what I'm going to do is I'm going to count the number of bonds that are on, So I'm going to count the number of covalent bonds that surrounds each carbon that's creating that double bond. And so here I have 1, 2, 3, 4. So since I already have 4 bonds on carbon number 3, I do not need to put in another bond to represent hydrogen. And so all of the bonds are filled up and there is no more vacancy for a hydrogen. Now, if I were to look at carbon number 4, I have 1, 2, 3. And so since I need 4 bonds, that fourth bond on carbon number 4 is going to be filled with a hydrogen. And so if you guys have only one hydrogen, so notice that this is a methyl, this is a methyl, this is a whole bunch of other stuff, right? And so if the double bond was your focal point, there's only one hydrogen that's found on one side of the carbon that shares that double bond. And because there's no second hydrogen in the other carbon that shares that's being shared with that double bond, like this example, right? There's how there's a hydrogen here, there's a hydrogen there on the carbons that form that double bond. Here, there's only one hydrogen, and since there's no other hydrogen on the other side, then we cannot use cis or trans. And so we're not going to be concerned with what it's supposed to be. There is another geometric isomer. It's called E and Z. And so E and Z isomerism is not something that we're going to cover in this semester. And so if you guys just have one hydrogen on only one side of the carbon and nothing on the other side, just leave it alone for now. And our final answer is going to be 3-methyl-3-pentanal. All right. And so let's go ahead and look at this last one. Here I have 1, 2, 3, 4, 5. And so it looks like I have another pentanal. Notice I have a double bond. And so I need to tell the reader where that double bond is. And so wherever the aldehyde, the carbonyl carbon on the aldehyde, that's carbon 1, 2, 3, 4, 5. And so following my numbering system, it looks like my double bond starts at carbon number 3. So I'm going to go ahead and put in 3-pentanal. And there's no other substituents, so it looks like I'm done, but one last thing that I need to do is just check my double bonds to see if there are hydrogens on carbon number 3 and on carbon number 4. And so if I focus on carbon number 3, that carbon number 3 has 1, 2, 3 bonds. For it to have 4 bonds, that last bond needs to go to a hydrogen. Excuse me. And for the fourth bond, the fourth carbon, it looks like it has 1, 2, 3 bonds. And so therefore, the fourth bond will be filled in with a hydrogen. So I want you guys to notice that we have a hydrogen that's on opposite sides of the molecule, right? So if we, for example, cut this in half, there's a hydrogen at the top, there's a hydrogen at the bottom. And so automatically, the geometric isomerism, the relationship, is going to be trans. And so to finalize the name of this compound, this is going to be trans-3-pentanal. And so some of you guys might think, okay, well, what does this cis look like? And so if you have, let me zoom out here. So if you have a cis, then you have something that looks like this. So this is going to be carbon, I'm going to zoom in. So this is going to be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. And so notice that on carbon 3 and 4, it has 1, 2, 3 bonds, so there needs to be a fourth hydrogen. 1, 2, 3, 4 bonds, so we need a fourth bond, and that's going to be filled with a hydrogen. And so since the hydrogens, if you guys cut like a plane, notice that the hydrogens are both on the same side of that plane. And so therefore this is going to be a cis relationship. And so the name for this organic compound would not be trans 3-pentanal, it would be cis 3-pentanal. And so once again, the main idea is that these hydrogens have to be present on both of the carbons that shares that double bond. All right, so that's pretty much it for aldehydes. I hope that going through some of these examples gets your mind processing on the pattern. So you guys are seeing the pattern on how to name these aldehydes. All right, so the next lecture video, we're going to talk about how to name ketones. So stay tuned. I'll see you guys later. Bye.